Okay, let's go ahead and begin. Today we're going to look at continuous probability density functions. Now before we get to that, let's go ahead and kind of get a bigger picture here and see how these continuous probability distributions are very consistent with what we've seen before and what we've studied in the past. So remember that what we started off with was statistics, okay? And we had the measures of central tendency and the measures of spread. And in particular now, we're just going to go ahead and focus on the variance as a measure of spread. But we talked about the mode, the median, the mean, as well as the variance. Okay, now, when we actually started off with statistics, remember that basically we had histograms, we had just raw data, and we had tables, charts, and basically what we needed to do then was take all of that data, arrange it in such a way that it made some sense, and so that we could then go ahead and generalize about the information. So we said that the mode was the most frequent value, the median was the middle value, and remember we said that we started out from the ends and then worked our way in. And then if we had things that were in intervals, then we could use the ogive to determine where the mean was. And then we said that if we wanted to go ahead and calculate the mean or the average, what we could do is if we had the frequency tables, we could go ahead and say the summation of the frequencies times it by the particular values of x of I that represent that frequency, and divided by the total numbers of total frequency. And then when we took a look at the variance remember was the average squared distance from the mean. And here's the difference of each one of your x of I values from the mean, square that to make sure that it's positive, multiply that by its frequency, sum all of those up, and then divide by how many values you actually have. And then of course remember that if we wanted to go ahead and find the standard deviation, we just went ahead and took the square root of both sides. Now after we looked at data, raw data from a statistical perspective, then of course what we did is we moved to a probability distribution. And remember that even though we have a probability distribution, we can still go ahead and analyze those distributions from a statistical perspective. And what we started off with was the discrete case. Okay, we said that if we have values of x that are countable and have probabilities associated with those values, then we could go ahead and come up with a discrete probability distribution. Okay? So what we said then initially was that, well, first of all of the probabilities have to be equal to 1, and that's going to be consistent with probability in general, and even for the discrete case. And then we said that if we wanted to go ahead and find the mode of a discrete random variable, then we needed to find the particular x of I value that would actually give us the max probability. Okay, and so if we found that max probability, then that x of I would be the mode value. Now, if we wanted to go ahead and find the median value, then what we needed to do is we needed to find out exactly where all of the probabilities would be less than or equal to a half. Okay, and so once we found this particular x of I value, such that it split the distribution into 50 and 50, then basically we found the median value. With the mean, this was where we actually introduced expectation. Remember, in terms of finding expectation or the long-term average, then what we did was we just took a look at each one of the probabilities for each one of the x values that we had for a discrete random variable, multiplied it with its particular value of x, sum all of those up, and came out with what we would call our mean value. Now the variance, of course, was exactly the same thing. It was the average squared distance from the mean, and we have, again, here's our x values, our mean, the square difference from that multiplied by its associated probability, add all of that up, and you come up with the variance. But remember that what we said is that the easier way to actually go about finding this oftentimes is by just taking the expectation of x squared minus the expectation of x quantity squared. Okay, and then again, same thing, if we wanted to go ahead and find the standard deviation, we just had to take the square root of both sides. Now, that was basically what we looked at from a statistical as well as the statistical perspective of the probability distribution of a discrete random variable. So what we have now now at our disposal, being that we've went through all of the calculus techniques, is we have now what is called a continuous probability density function. So notice that we're talking about here is a density function because of the fact that our function is now going to be continuous. And because of that, we're going to have all of these particular values of x that we will go ahead and use to determine certain probabilities of this continuous function. So what we have then is generally our probability density function is going to look something similar to this. It's going to be an explicitly defined function. And the reason for that is because we need to make sure that our domain is specific enough so that we can actually make sure that the probabilities, if we integrate p of x d of x, it will always come out to 1. Okay, so notice that we still have very much consistency between the discrete and the continuous case, but then in this case, instead of the summation, we're looking at the integral from a to b. Okay, and then even if we go ahead and take a look, say for example at the mode, how do we calculate the mode for a continuous probability distribution? Then we again do the same thing, we look for the maximum value of p of x, and whatever that x value is, that would be the mode value. Now, when we wanted to go ahead and take a look at the median again was the middle value, and basically what we're looking for is a particular value of x, and let's just say that x of I is equal to k, and it's going to be someplace on the integral from a to b, and what we know then is that, again, it has to split the probabilities into 50 and 50%, and so therefore if we go from a to k of p of x d of x equaling 1/2 and solve for k, you found your basic median value. Now, with regards to the mean, notice that the mean is going to be exactly the same thing except for, instead of the discrete case, we're talking about the continuous case. So what we're doing again is we're just taking the x value, multiplying it by its associated probability and integrating from a to b, and again that is going to provide us with the mean value or the expected value. With the variance, basically it's again the same thing. We're going to go ahead and take a look at this form here to show the relationship as how those two are connected, and saying that this is just going to be the integral from a to b of x squared times it by the probability density function p of x d of x, integrate that, and then subtract the expectation of x, quantity squared. So I'm hoping that what everybody can see is by having it spread out this way so that you can see how we took a look from a statistical perspective first with the mode, the median, and the mean, whereas measures essential tendency and how to calculate the variance. Then we moved that to the discrete case of our probability distribution and our probability discrete random variables to now continuous random variables associated with our particular probability density function. So I'm hoping that the consistency is very apparent now to you, and I'm hoping that that's going to make things a lot easier to remember how to calculate all of these different particular statistics for either statistical data, discrete data, or a continuous data given by a continuous probability density function. Okay, so we'll take a look at some of these in class, go over them together, and hopefully we'll be able to go ahead and calculate all of the different statistical values for a continuous probability density function. Okay, see you later. Bye.